Hey, what's going on, guys? Let's do this problem right here. The question is asking a proton moves east with a speed of 4 times 10 to the power of 6 meter per second in a magnetic field of 2 times 10 to the power of minus 4 Tesla directed into the page. What is the magnitude of the magnetic force acting on the proton? Let's see how we can find it. So let's put the equation for magnetic force first. So we know that since it's related to speed and everything, the equation related to this is going to be BQV sine theta. And here they have mentioned that this one moves to the east and this is directed inside the page. So it means the sine theta is going to be 90 degrees. It's going to be perpendicular to each other. So sine theta is going to be 90 degrees. So we know that sine 90 is equal to 1, right? So we only have to deal with this one right here, BQV, because this is just going to be 1. And the question is asking for the force, so we don't have to change anything. We just have to directly apply the values. So here we have the magnetic field that's provided 2 times 10 to the power of minus 4 Tesla times the charge of the proton. That's something you have to know. The charge of the proton is 1.6 times 10 to the power of minus 19 coulomb, right? And then velocity that's provided 4 times 10 to the power of 6 meter per second. 4 times 10 to the power of 6 meter per second. And if you calculate this one, that's going to give you the force, right? And yeah, this is Newton per Ampere. Okay. Let's analyze the unit first. Newtons per ampere meter, right? Tesla is equal to Newton per ampere meter. And ampere is same as coulombs per second. And here we have Newtons per ampere meter. So let's write this one instead of coulombs per second. Coulombs per second, I can bring the second to the top because per second, that's same as flipping around, right? Coulombs per second multiplied by coulomb times meter per second. And if you notice, meter cancels, coulomb cancels, and second cancels, and finally we will end up with Newton. And if you calculate this value, that's going to give you 1.28 times 10 to the power minus 16 Newton. And that's going to be the force acting on the proton. I hope you guys find this video helpful. See you next time.